You're watching an unexpected visitor from deep space. Meet 3I Atlas, the third interstellar object ever spotted by human beings through the Atlas program. And Chinese scientists captured several incredible snapshots.
While NASA remains silent, waiting out a U.S. government shutdown that has frozen the release of its high-rise images of 3I Atlas, China has already moved ahead, and the world is watching. In a surprise announcement, the China National Space Administration, CNSA, unveiled the first-ever interplanetary images of the interstellar visitor, captured by its Tianwen-1 Mars orbiter on October 3, 2025, from nearly 29 million kilometers away. As the United States stalls, China acts. The release wasn't just a scientific update, it was a statement. At a moment when the West's most advanced Mars camera sits idle, Beijing's spacecraft quietly turned its lens toward a cosmic stranger from beyond our solar system and made history first. The achievement required extraordinary precision. According to Chinese state media CGTN, mission controllers rehearsed their imaging plan for days before the encounter. They used Tianwen-1's high-resolution imaging camera, known as HIRIC, to test exposure times and verify the comet's trajectory. On October 1 and 2, the orbiter executed trial runs, capturing calibration images to confirm pointing accuracy. When the moment of closest approach arrived on October 3, the spacecraft successfully locked on to its faint target nearly 29 million kilometers away. Engineers likened the challenge to photographing a sesame seed from a kilometer away, while both you and the seed are moving at tens of kilometers per second through space. 3I Atlas, discovered by the Asteroid Terrestrial Impact Last Alert System in 2024, is the third known interstellar object, after Oumuamua in 2017 and Comet 2I Borisov in 2019. By the time it crossed the orbit of Mars, astronomers estimated its nucleus to be roughly 15 kilometers across and glowing at magnitude 6.7, too dim for unaided human vision. Fast, faint, and ancient, the object presented an ideal test of Tianwen-1's capabilities. The orbiter itself was launched in 2020 to study Mars, but its extended mission has turned it into one of China's most versatile deep space platforms. When Avi Loeb, the Harvard astrophysicist known for his open-minded views on interstellar visitors, analyzed the Chinese images, he described them as fuzzy yet revolutionary. Writing on Medium, Loeb pointed out that although the photographs do not resolve fine surface details, they capture an object that once wandered the void between stars for billions of years. To him, these snapshots signal a new phase of interstellar research, one in which humanity's robotic explorers can act as vantage points far from Earth, photographing cosmic travelers from multiple perspectives. Still, the photos raised more questions than they answered. In Loeb's assessment, 3I Atlas appeared unexpectedly compact, showing no obvious dust tail, the luminous streak that typically forms when a comet's ice vaporizes near the sun. Was the absence of a tail merely an artifact of the camera's settings, or was the object intrinsically different from familiar solar system comets? Loeb noted that the camera's exposure, viewing geometry, and the scattering of sunlight could all mask a faint tail, yet the mystery lingered. Why was the third interstellar object in a row, after Borisov and the much-debated Oumuamua, displaying features that defied easy classification? For Chinese scientists, the Tianwen-1 imaging campaign was as much a demonstration of technical prowess as a scientific investigation. The ground team emphasized how little time they had to prepare. Astronomers first detected 3I Atlas in July 2025, leaving only a few months to calculate its orbit and plan the complex tracking sequence from Mars orbit. The successful images proved the spacecraft's fine pointing control and offered rare data for photometric analysis. Beyond the immediate science, the event underscored China's rapid ascent in deep space exploration. From the Chang'e lunar missions to the Tiangong space station, each success has broadened the nation's ambitions and its willingness to engage in high-risk, high-reward experiments. But just as Beijing celebrated this achievement, another story began to unfold closer to Earth. On November 5, the China Manned Space Agency announced that the scheduled return of the Shenzhou 20 crew from the Tiangong station would be delayed. The reason, officials said, was a suspected debris strike on the spacecraft's re-entry capsule. Engineers were conducting impact analyses and safety assessments before authorizing descent. The three astronauts, Chen Dong, Chen Zhongri, and Wang Yap, remained in good health and continued regular operations, but their return date was uncertain. The announcement triggered speculation online. Could the Shenzhou capsule have been hit by a fragment from 3I Atlas? The timing seemed curious. The comet had passed near Mars barely a month earlier, and Earth was now approaching its own encounter with the interstellar wanderer. Social media posts and amateur commentators suggested that a dust particle from the comet's tail might have entered Earth's vicinity, striking the orbiting capsule and forcing China to delay the landing. The idea was thrilling, cinematic, almost too perfect. Yet when examined through the lens of orbital mechanics, the scenario collapses. Orbital debris, the term used by the Chinese agency, has a specific meaning. Fragments of defunct satellites, rocket paint chips, and discarded hardware circling Earth. These pieces travel at roughly the same altitude and velocity as crewed spacecraft in low Earth orbit. In contrast, 3I Atlas follows a hyperbolic trajectory through the solar system. Even if it shed dust near Mars, those particles would continue on independent solar orbits, not form a ring of material around Earth. For a fragment of 3I Atlas to collide with Shenzhou 20, it would need to decelerate by tens of kilometers per second, an almost impossible feat without atmospheric braking. Still, the thought experiment reveals the uneasy truth about our increasingly crowded orbital environment. Space agencies monitor tens of thousands of tracked objects and millions of untracked ones, any of which could threaten spacecraft. The fact that China publicly acknowledged a possible debris strike on a crewed vehicle underscores how serious the danger has become. The interstellar visitor may not be to blame, but the incident reminds us that humanity's technological detritus now poses a greater hazard to astronauts than any comet could. If not interstellar dust, what then explains the missing tail of 3I Atlas? Several natural explanations fit the data. The comet may simply be composed of large, heavy dust grains that are less affected by solar radiation pressure, producing only a compact, faint halo rather than a sweeping tail. Alternatively, the viewing angle from Mars' orbit might have hidden the tail, aligning it behind the nucleus relative to the camera. Another possibility is that the comet's volatile content, its ices of water, carbon monoxide, and other gases, is unusually low, limiting outgassing. Each explanation preserves the comet's natural origin without invoking exotic physics or alien engineering. The alien spacecraft idea, however, refuses to die. Ever since Oumuamua flashed through the inner solar system in 2017 with its peculiar cigar-like shape and acceleration that some argued was inconsistent with cometary outgassing, the notion of interstellar probes has captivated the public imagination. Avi Loeb himself has entertained the possibility that some interstellar objects could be artificial, remnants of technology from other civilizations. He stresses, though, that such hypotheses must rest on evidence, not inference from mystery. Extraordinary claims require extraordinary data, he often reminds his readers. For 3I Atlas, no such data exist, only fuzzy images and the human tendency to see intention where randomness reigns. Yet dismissing curiosity outright would be a mistake. Each of these visitors, Oumuamua, Borisov, and now Atlas, expands our understanding of the galactic environment. They confirm that fragments of other planetary systems routinely drift through interstellar space and occasionally pass within reach of our instruments. They also remind us how limited our perspective still is. From Earth's orbit, comets are fleeting specks. From Mars' orbit, even with a high-resolution camera, they remain blurred dots. The distances involved dwarf human intuition. Every photon captured from 3I Atlas traveled millions of kilometers, carrying information from material forged around another star. As December 19 approaches, when the comet will make its closest approach to Earth, telescopes worldwide are preparing for coordinated observations. If the object brightens as predicted, amateurs may glimpse it through backyard optics, a pale smudge moving slowly among the stars. Professional observatories will attempt spectroscopy to decode its chemical composition, comparing it with the interstellar comets before it. Whatever they find, the Chinese images from Mars will remain the earliest and most distant portraits of this traveler. The episode also demonstrates how international space science now unfolds as a mosaic of overlapping efforts. While Western agencies track interstellar visitors with ground-based telescopes, China is using its Martian orbiter as an ad hoc deep space observatory. Each perspective enriches the collective understanding. Science thrives on such multiplicity. One planet's orbit sees what another cannot, and together they stitch a fuller picture of cosmic events. From a narrative standpoint, it is tempting to draw symbolic parallels. On one hand, humanity's machines circle two worlds, Earth and Mars, watching a body from beyond the solar system. On the other, a human crew aboard Tiangong delays their return because of a strike by debris born of our own technological proliferation. The interstellar and the anthropogeneic converge, illustrating the dual nature of our cosmic story. We reach outward to the stars while littering the near-Earth environment that sustains our reach. In the end, 3I Atlas remains what it always was, a messenger from the deep past crossing our system on its way back to the void. Whether its surface hides exotic metals or mundane ice, it carries information older than the sun itself. The fact that we can now image such a traveler from another planet's orbit speaks to a civilization learning slowly to look beyond its cradle. And if, somewhere in that faint gray blur, there exists even a fragment of the unknown, a hint that other minds once looked out from their own skies, then the story of 3I Atlas is only beginning.